My name is Natalia. I'm a data quality assurance manager here at Quantori. And today we're going to talk about data QA. Who is it? What is it? And why do you need about it? A little agenda. Today we are going to define the data and data quality, observe some examples of the data, know what are ETL and ELT systems. Maybe you've already heard about them, understand the place of data QA in projects, see an example of the data QA responsibilities, and we'll look at some case study today. We will compare data QA with other roles to eliminate the misunderstandings in that role, and we'll note a portrait of a data QA just for fun. And then we will have a Q&A session. And if you have any questions, as Anna already said, you can type in the chat or you can ask later after the lecture. Let's get started. It's going to be a very high-level and introductory lecture, by the way. So we will start from the very basics. I'm pretty sure you already know what is data and potentially you know what is data quality, but still let's refresh. Data is basically a collection of discrete units of information, which represents usually quantity, quality, facts, statistics. All of us generate tons of data on daily basis, and you can see on this picture the sources of data. It's social networks, it's Internet of Things, it's banking transactions, it's laboratory data, it's transportation, and all around, like the world around us, it's all about data. If we are talking about not the information but the data usually is organized into structural way. Usually it's tables, but not necessarily. You know, there are many different formats like JSON, XML, CSV, etc. Data may be used as variables for computational purposes, and on some data units, you can create some new data by calculations. And data may represent both abstract ideas or some concrete measurements. And that's what we are going to work with. It's just the basics. Talking about data quality, it's kind of a science, and there is books written about data quality, but very shortly, there are 6 basic data quality aspects, which are completeness, accuracy, consistency, integrity, timelines, and validity. We will not get into much details about it. I just wanted you to know that there are real aspects we are working with, and we preserve them in the data projects. On this slide, you can see some examples of data we process. I put the examples from life science. It's all medical records, experiments, laboratory data, patients' records. And here at bullet points, you can see the main, I would say, properties of such data. So it's represented in different formats. It's sometimes very unstructured, very noisy. It's huge volume. It's billions of records. Sometimes it's very sensitive information, which is under restrictions like GDPRs and required anonymization and stuff like that. And all of that data aspects impose on us testing and impose many problems which we face when we process the data. So what are the problems? Here you can see 3 main groups of the problems which we usually face working with the data. It's mapping problem, matching, and merging. Let's see what is it. Mapping problem is about mapping rules when you get the data from different sources and you want to represent it in a structural way. You have to decide what data you choose, you pick and you work with, where you get it from, where you put it to, in which source, which target, for example, warehouse or database, and how you do it. So the data is moving from one source to another, and as a QA engineers, we should validate those meta rules. So we have to understand the nature of the data and how to map the data from one source to another. And also, once the system is developed, we check that all the rules are properly followed in the developed system. Mentioned problem is about finding the same data in different sources. As I already said, we usually get the data from different sources. Let's say we have a pharmacy, we have a hospital, we have some private clinic, and all. Then we just gather the information from all the sources, and potentially we may have the same data in different sources, but in different formats and different representations. And matching is about that, like we make matching rules. Again, we should understand very good nature of the data. What is it? We have to understand the domain. Then, as a QA engineers, we analyze the rules and then preserve that the rules are followed again. And merchant one is very interesting because when I'm talking about data processing, I usually talk about the flow, and it's not working like we got the data once, processed, and put into a warehouse. Usually, it's a repetitive process which is repeating on daily, hourly, monthly, yearly basis. So here we think of how to merge the old data with the new ones. And it's again, there are some rules, some approaches how we can do that. We can do appending, augmenting, data looking up. And as a QA, again, we analyze the rules and we check that we actually don't lose the data while merging. It's a very interesting task, by the way. And now again, like a very small theoretical block about ETL and ELT systems, because not everyone knows what is that. I just wanted to explain here that these three letters stands for extract, transform, and load. So basically, the schema is like this on the picture. We extract the data from different data sources. It's usually called data ingestion. Then we process the data, we somehow aggregate them, map, match, and this block is called transformation unit. And then we load the data into a target place, warehouse, database, from where data consumers can extract it again and use for their own purposes. This is usually how it works. It's about ETL, ELT is pretty the same, but you see the order is different. We firstly extract, load, and then we just transform and build some views on top of already loaded to target warehouse or database data. So that's the concept of ETL. And if ingestion and load to target warehouse is pretty straightforward, so it's understandable what is that. Many questions usually about data transformations. So in ETL, I just wanted to show you the examples of the transformations in very basic level. It can be just copying or partition the same data from one source to another, so you don't make any transformation. Actually, it's also transformation, like a zero level one. You can change data types, for example, to double to int. You can change formats of the data. You can decode data, for example, if you have country codes and you need to store the country names. So you do some basic decoding. You may create some new data, as already mentioned, by calculations. You can concatenate, can parse an opposite, can filter some rows. If you got some noisy data, you don't need all of them, you can filter. Data structure conversions, and that's it. Actually, there are plenty of different transformation, but that's just basic, very often ones we work with. So now another block is about place of a data QA. The project should be interesting for all of you, because usually when we speak about QA engineer, oftenly we imagine some client server application, and we think about functional tests. With respect to business logic, we think about non-functional tests, but again, with respect to application, front end to back end, often QA engineer tests the system using like end user mindset. Like you think as a user, and as a user, you want your system to work this and this and this much. And this testing can be potentially performed fully manually, not necessarily. Of course, there are maybe include some automation tests, but not necessarily. Now we are kind of doing a zoom out. Yeah, and usually there is a databases in such applications. And if you are working with a database, if you're kind of a data quality thinker, so you preserve the rules, the integrity of the database, you can be considered as a database tester. And if you multiply, for example, if you don't have only one application, and if you don't have only one database, the complexity increases, and you get more and more a database tester. And when you do the same like testing types, you again have functional, non-functional, but all of them are with respect to the data, not the application logic and not the business logic. Megan doing kind of a zoom out, and here we are going to have an ETL testing. As I said, you may have different applications. Each of them has its own database. You store some different data. And we are interested in extracting all of those data from many different sources, then transform, somehow process the data, and load to a warehouse where we can provide our data customers with business. Like this process data has a very high business value, because on top of that process data, businesses can kind of make business decisions. Yeah, again, we are now in ETL testing, and it's kind of another type here. You again do the same testing types like functional, non-functional, but as ETL tester, you more think not really about like the data itself, but the data processing, the data flow, like how often you repeat, for example, the process, and what potential leakages can be here in that process. And as I already mentioned, you think about merging problem. You remember the merging problem? So it's very, very applied to ETL testing here. And from such kind of tester, it requires a very solid SQL knowledge and automation too, because it's very complex and hard to do manually sometimes, so you have to know how to do it automatically. And on the other end of such systems, we can see the BI testing. You may already be familiar with such work as a BI testing. It's again usually like you have some website or application where you work with data visualizations with some graphs, or maybe you have some machine learning model which also does some predictions. And using BI tools, you build such systems, and you again should be able to test it. So you're kind of on the other end. Here we have many like data providers multiplied by n. Yeah, and at the end you had a very long pipeline, and at the end you have some nice graphs, nice representations. Yeah. Again, such testing can be done fully manually, but not necessarily, and you don't really require programming language skills here if you test such systems. Here is an overview what I've already just said. Data testing, talking about the testing types. Again, here we have white box testing and black box. And talking about white box testing in terms of data, we usually think of tables, table columns, views, stored procedures, functions, triggers, and stuff like that. When we talk about black box testing, it's again functional, non-functional, and here we have DML operations, transformations, integrity, and all that I already mentioned. Non-functional is the same, like performance, security, but with respect to the data. It's kind of the overview what I just already said. And now we are going to see at a case study. So we will consider just regular ETL project without data QA and ETL project with data QA. If we have, I don't know, DMs on the call, listen now, maybe you need a data QA. You're going to realize it. So basic project, we have some ETL system, you see extract, load, transform here, and load some data warehouse. And at some point, we decided that we need to make a change in that project. So we do the change. And here is a question. Are there skilled QAs in the project or not? Let's imagine that no. So then validation is done by who? By the developers. What usually developers do, they write their basic unit tests, and in best case, they go to the target warehouse, they compare the overall counts of the data, and they make sure that at least all rows needed are presented in the warehouse, and that's it. What is going on when we have data quality at the project? Data quality goes to the project and starts the whole QA process. There, starting from test data preparation, and here is some approaches how we can do that. Data QA does some basic validations again, and not only the basic ones regarding to the approach which is implemented. Remember, like a good QA usually reviews the architectural decisions and also the approach, and that rules the mapping, matching ones, and merging. So it's also the subject of testing. Then we have such an activity like regressions, minimizations. Yeah, when we do some changes in the system, usually we expect that we may potentially break something in the system, so we minimize the impact of regression bugs in the system. We again can do performance and security checks, and what our customers like very much is the extensive documentation. So we not only test, we also document each and every step. We can do some kind of formal testing. We can prepare the documentation for audits, and it's also very valuable activity. So as a result, our customers will have higher quality of the data, their source is more trusted, and very nice thing that development team has more time on the engineering tasks. They are not loaded with the testing types. It's just not necessary. Talking about technology stack, all the testing tools applied, of course. We work with some programming languages. We work with different databases in different methodologies. And like I just highlighted what we work more, but all of this is applied, and the technology stack may really vary depending on the project. Talking about manual data QA is the only core skill which we require to start in this profession is DML, data manipulation language. You may already all know what is that, but I just to refresh your knowledge, what other creation we have is just basic one. And this slide can be useful for people who already work with data. I don't know, you have a QA or you don't have. Maybe you're just interested in some common cases which we usually face. So let's see what to pay attention to when you work with data. So you check that required values are not null or blank. They should not be. Another example is record count for sources and targets mismatch. It's what I mentioned, like usually developers check themselves if they don't have QA, and that's it. Out of boundary values, it's again like the data characteristics and requirement stuff. Often we have duplicated roles. It's going back to like merging problem. You see, we are not only can meet the situation when we lost the data, we can have more data than expected. Yeah. Incorrect data formats, especially it's met in date and time, because the different system has different requirements to data timestamps. An example of the bug is broken numeric field precisions. Like you have some rounding rules and they are not followed, or you just got some values at the not correct number of signs after the dot. It's just examples. Of course, there are plenty of different bugs, but if you work with that, just pay attention to that. It's just small checklists what to pay attention to. So the last block for today is about, so who is data QA after all, and let's compare this role to the others. One of the most common questions to me is data QA, is it an automation role or not? I would say that not, because you not always automate your tests. You can just write SQL scripts, and as I already mentioned, is the main requirement to this role, but it's very nice if you are able to automate your tests. It will help and optimize your work, but not necessarily. So manual data QA is proficient in data processing technologies, knows a lot about ETL and ELT, knows about data quality aspects, works with data pipelines and architectures, proficient in SQL, of course, that's the main requirement, yeah. Able to write optimal tests, because even in SQL you can sometimes solve the same problem by different queries, and it's nice if you understand which one is more optimal, which is works faster, because often you work with big data with a very huge amount of rows, and performance matters. In most cases, you can write your scripts and execute manually, and it's not necessary to be advanced in programming. Yeah, you can just know basic you have basic knowledge, and that would be enough for this role. In opposite to automation role, you are not necessarily aware of data, about data processing. For example, you're automating UIs or APIs, so you don't care about data systems. Again, like here, may not know specifics of data pipelines, testing, but you should be proficient in programming languages. You have to know how to write very nice code and to test systems in automation ways required for AQA. Pretty straightforward, right? Again, comparing to BI engineer, the main data QA is the same part, and talking about BI engineer, it's again like still the role which works with the data mostly. So you have to be aware of data processing, building data apps techniques. You should know specifics of data pipelines, testing, and developing in ideal world. Yeah, you again proficient in SQL and stuff like that. Like the main point here is that you have to be skilled in data modeling, data visualizations, and you know this business domain like budgeting, cost monitoring, and stuff like that. Sometimes my friends say that I'm not a QA, I'm a skill developer. So that's why it is here. Also, another question, the same for data QA and SQL developer. It's you see the competences is very close, but the main difference I would say in the focus. If you're a QA, of course, you're focused on quality assurance activities, and if you're a developer, you're more about like development and engineering stuff. But again, very, very close roles. And I put those comparisons here also to broaden your horizons. Like maybe you find something interesting for yourself. The last comparison is about data engineer versus data QA. Data QA here and data engineer, I would say, like should be proficient in all of the stuff except for testing. Yeah, but data engineer proficient in the data architectures, working with big data, proficient in SQL, assembles large complex data sets, and etc. etc. So it's kind of a superhero. And here is an overall table. Everything which I said above, you can see in this table. So talking about data QA, it's almost like competences of everything except for data architecturing and BI tools. AQA is mostly about testing QA basics, of course, and programming. BI engineers, BI systems, and ability to work with data. SQL and data engineer, you may see here, it's very close to all. You see here is many intersections in this role, but you can choose what you prefer. And I would advise to start with the focus. What do you like to do more? Do you like to work with quality, with testing, or you prefer building a product, develop a system? So depending on that track, you decide either this career path or this one. And then you may see, for example, which skills you like more, like most, and then you can choose what to do next in your career. This is just for fun, portrait of a data QA. Such person is usually technically skilled, knows how to improve the data, structural thinker, and well organized, and of course communication guru as each and every QA, I believe. Do you like such a person in your team? I hope yes. Here is some takeaways if you are interested in the topic. I put up some books, videos, and checklists for you if you want to have something after the lecture. You will have a presentation to click it. And the last question is why? Like, why am I here? You may be asking yourself, yeah, why should I know all about it? The idea of this lecture was to show you probably an interesting career path for you, or maybe you listen to me and understand that you need a data QA at your project, or maybe you already play the role of a data QA in your project, but you don't know about it. And finally, just for fun, just broaden your horizons. I hope that it was interesting